Well, welcome back to the Azure Podcast. This is episode number 399, being recorded on the 21st of October, 2021. On Teams with me, we have Cale and Evan. And for those on YouTube, uh, Evan is,
I'm a circle today. Yeah.
he's a circle. We don't see his face today, so don't be surprised about that. uh, yeah, for the audio folks, it's all business as usual. Well, today we figured we hadn't really had a good discussion on our favorite topic, and that is blockchain, right? The chain of blocks, as Kale has now started calling it, and so we decided it's about time to get a let's get an update on where we are, where Microsoft is, where Azure is, and where just generally this technology is going in the space. So we're going to have a discussion on that with, of course, Kale. But before that, there's a few news items. I know last week Evan and I covered a lot of news updates. There's a
But
few
we
more.
skipped one of my favorite ones. I was so upset. We'll hit it this week, but we totally skipped it.
Well, go ahead, Evan. Why don't you get started on that then?
So we skipped space cows last week. So and this is the actual article. We'll include the link for everybody. But and apparently, and I don't mean to make fun of it because it apparently they're a really bad pest. But like here in the U.S. we have feral hogs in some of the parts of the Midwest. In Australia they have feral cows and cattle. And so they destroy crops and other stuff. And so what they're doing is they're tracking these with low power tags, and then they're feeding all that into an AI system so they can predict where they think they're going to be, so that the farmers can get notice and can do the necessary way to keep them from coming onto their land. So that's space cows, but it's pretty cool use of both the Azure Space capabilities as well as the AI ML, and like I said, we'll include the link in there. It also makes me think of was it Muppets that had space cows as well? I think, yeah. I just have this mention of space cows going through my head, but I can't place where it's from.
I'm glad you mentioned it because Kale also was going to talk about it, but it's okay. You covered it.
Take that, Cale. We're talking about blockchain today. I get to get the news.
Fun fact: I've delivered many cows in my day when I was younger, because I'm from Pennsylvania originally, and so I'm amazed that cows could live out there by themselves and like reproduce like that. 'Cause I know what that takes to deliver a calf. It's not easy.
Excellent.
Well, I'll cover a few updates, specifically with Azure Spring Cloud. We had a bunch of updates. That's one of my pet Azure services. I just recently finished an engagement that deployed Azure Spring Cloud for a financial services customer, so it's something that's on my mind. And a few updates that came in place over there. One is, Spring Cloud is basically a Spring Boot server with some associated other services like they call the config server and the registry server. So those are things that are part of the whole Spring Boot environment. And Spring Cloud runs all of that for you. So the beauty of Spring Cloud is you don't have to worry about all these services. You just get everything out of the box. It basically deploys a couple of Kubernetes clusters for you and runs everything for you. It's a black box for you for the most part. However, to access those from your application, if you need to access the config server or access the registry server to get configuration information or find out where other services are, getting access to the other services in a secure way has been a challenge. And so now they've introduced the RBAC, Azure, they integrate now those two services, config server and the registry server will can make use of Azure AD RBAC controls, and so you can specify, okay, only a client that belongs to that particular role can access, and this way you kind of control who has access to that to those two services that are on your network there. So that's one part. The other part is, although this is all a black box, still there are components that are deployed for you. Things like Nginx controllers, AKS clusters, etc. And you do want to get some insights into some of those internal controls because, for example, there's latency in your call. You want to know exactly where it's slowing down. You still want to have some insights into that. And so now the ingress logs from those Nginx controllers can now be made available to you. So that's another update that came into Azure Spring Cloud. Two more that also came up again in the monitoring space. You can now get a full end-to-end monitoring of the application lifecycle. So as applications come down and go up, or if they're in the unstable state, things like that, you can get alerts and notifications on it. And I'm particularly proud about this one because this is, I believe, one that I brought to the attention of the product team. I remember way back when in my engagement, and so I'm glad to see that they're taking some action and done something about it. But this gives you all of the application lifecycle changes in Spring Cloud are now surfaced up, so you can figure, hey, why did this app recycle? Why did it go down? Things like that. Otherwise, it would just in a black box, it would just recycle it and not tell you about it. And that was kind of frustrating at times, So
So
they
this
fixed
is, you're
that.
talking like if the app is crashing or if somebody pushes an update, all that shows up in the activity logs at that point.
Yeah, and also if
Okay.
it does it on its own, the way Spring Cloud is, it tries to keep the app up and running. So if it goes
Right.
down, it just brings it up right away, but doesn't tell you that, hey, it went down, you should go look at it, or go do some research and see why it went down. So that was not very apparent. You had to go and look at 1,000 logs to figure
Gotcha.
that out.
Okay.
Now that's those lifecycle changes are being highlighted. And then again, because we have these intermediate things like Nginx controllers and your actual Spring Boot endpoints and whatnot, they've now introduced end-to-end TLS. So originally it was the TLS was being terminated at the Nginx controller, and then it was going just internally in your network, was unencrypted. But now, of course, customers and everybody wants encryption everywhere, and so now there's end-to-end TLS that can be easily turned on in this particular case. Oops, let me turn that off. Sorry about that. And then two more updates, and these are real gems actually. Visual Studio Code, which is our favorite editor, is now available on the web. You don't even have to install.
I saw that. That is
code
cool. Yeah, that is
Isn't
cool.
that cool? Yeah.
Yeah.
And so you just go to, I believe it's vscode.dev, DEV, and you get a whole Visual Studio Code. Of course, now it doesn't have access to any of your files on your computer, so you gotta open it up. You gotta tell it which files you want to open up and edit, but you get a full editing experience, right? You want to quickly edit in like an HTML document, or look at a log file in a nice way. You have access to all of the extensions and everything that Visual Studio Code has. But you have it in the web. You don't have to install anything on your computer, especially if you're away. I don't know, maybe sitting at an airport. I'm not sure when that'll happen next, but if you're sitting in an airport on a kiosk or a terminal or something, you could just quickly get to from there. And then kind of just a quick addition to this, and I'll be done. Is I don't know if folks know, but in GitHub, if you're at a repo and you just press the period, the dot on your keyboard, it'll actually open VS Code for you. It's like a not a well-known keystroke, but just press the period while you're looking at the repo, and just like that,
that is cool. Okay.
it'll open up VS Code with your entire repo up, and you can do some light editing. You can make some commits right on the web. So
Nice.
that's been there from before. That's not new, but it's related to the update I just talked about with VS Code on the web, because obviously, VS Code on the web is the same concept. Now, one thing where they call out that it does not include any compute charges, so you can't actually run any code. You can just edit it, right?
Okay.
Of course, this is kind of like a little bit of I wouldn't say gimmick, but it's a little way for you to start looking at GitHub code spaces, which is kind of the next level up, right? With GitHub code spaces, you get the VS Code experience, but you can also run the code. And for that, you need, of course, GitHub code spaces, which is a paid service. Again, you don't have to do that. VS Code on the web for free for everybody right now. Cale, what do you have? Anything before we jump onto our topic?
We had lots of news. The only one I'll drop in today is the Enclave device blueprint, because it kind of applies a little bit to what we're going to talk about with blockchain, and it's around confidential computing. So there's a really nice write-up here. They call it this blueprint around the edge and how to use these enclaves at the edge, because these are becoming much more prevalent. I mean, in the old days, I say old days, it's probably been like 5 years ago or so when SGX first came out. That was the standard kind of for what we used here. Now these things have kind of proliferated a little bit more. So you don't just have to have a server running in the cloud to have this exotic hardware. There's actually devices that are coming out and being able to be run on the edge, right, and provide that trusted computing base and things like that. So super cool. Take a look at it.
Awesome. Well, I guess then we can get on to our topic of the day, which is the chain of blocks, as you put it, Cale. So, it's been a while since we talked about blockchain. I remember way back when we discussed it last. It was like blockchain as a service was being discussed, and we had all these plans. But just bring us up to date on at least on where we are or where you are in that whole life cycle with blockchain.
Yeah, sure. I'll talk a little bit about like where the industry is with it, like from an enterprise standpoint, as well as like Microsoft's thing, obviously from Azure perspective. So, as we talked about before, I think we've had a few podcasts about blockchain, talking a little bit about the infrastructure, some of our developer tools and things that we built, and then progressing to things like NFTs. I think we did an episode about that as well to let people know what those things were. But basically, the idea is similar. It's just evolving, right? So almost 6 years ago now, we started working on blockchain here, and mostly B2B type scenarios or B2C. And what that would be is, essentially, businesses optimizing the way they integrate from a data platform perspective using blockchain tech. And we've talked about that on other podcasts, and that still holds true. And we've had great success there, right? Specifically, I'd say the biggest use cases have been around things like supply chain, where you have components or things that are involve multiple parties. Anytime you're thinking about multiple parties, blockchain, it should be thought about, right? It's not always the answer for it, but if we have to share some data and it's a consortium or a group of people who need to share that data, it makes some sense in some cases. So supply chain, some financial transactions, things like that have been really good success, bond platforms, things like that. But over time, so Microsoft built up. I worked with the team, and we worked with a lot of third parties. I think we had about 160 ISVs we were working with at peak, and then we started building stuff as well. First party, we built the Azure Blockchain Service, Blockchain Data Manager, a bunch of other services around that to make it easy to prototype and run these applications. And as things evolve, right, there's peaks and valleys, and over time what happened was the backend that we use, which is called Quorum, was originally developed by an engineering team at JP Morgan Chase. So they were kind of an offshoot engineering org that built an Ethereum variant that worked for enterprises to do private transactions and whatnot. So what happened was probably about a year ago, Consensus, who is a big partner we work with here in Brooklyn, they bought Quorum from JP Morgan. We work with both of these guys. We've been with Quorum since the start. We've been with Consensus from the start. So, we're a close friend circle here. And we were like, okay, so we built this thing that uses Quorum. Now you bought the product. Okay, we should talk about the future here because our product's in preview. And so like ABS has been a great success, from like standing up, within 5 to 10 minutes, you could have a blockchain system running, you could bring people into it. But then, there's some things we wish we could have done, right? More like maybe more decentralized, maybe let the data reside out at the partners more or the customers more. There's like a balance there, right? Between like if we put everything into one tenant, it makes it easy to run, but if we spread it out, it gives more decentralization and makes a little more sense for certain cases. So anyway, talked to Consensus, and I've been working with them for a year, and it just launched was QBS, which is Quorum Blockchain Service. So Consensus owns this one, but I talk to customers and partners all the time, and they're not even aware in some fact that Microsoft engineering has had a big play in there. We've been working with them from the start to make sure that runs really well on Azure. People can power these things up. It's actually available. We're in a migration process right now with existing customers, but you'll be able to get this through the marketplace as well. So it's a fully supported product that Microsoft is very close with Consensus in building on this platform. Just a couple other things, and then we could talk more questions or whatnot. But the continuing ecosystem of all the stuff around it, like our VS Code extension, will continue on. We're continuing to support that community, and I think what's happening is like all up in general for blockchain. Over time, we build a lot of private blockchains. That's what enterprises typically do. They don't put things out where public cryptocurrency that you might have heard about in the news. We're not typically running stuff out there. That's changing a little bit. Like there is some migration happening to that, but I think what's really evolving is this thing called a sidechain now, which basically is a new way to run kind of like private blockchain. So essentially you can anchor something to and prove something really strongly up into like a public infrastructure, but you can keep all the other data off chain. We'll say off chain of that main trunk, right? And that's why it's called a side chain. So
So,
a lot
so,
of lot
so
there.
just to make sure, Cale, just to make sure I understand that, because we talked about this a few shows back. So this is sort of like forking off a piece of this, and you're now gonna, you have these sort of private properties, for lack of a better description. Does this eventually merge back into the main chain, or is it always going to sort of run parallel? So you're going to have this little subset of properties that are sort of private and hidden from the main blockchain, but they're still the core, sort of the core object is still tied back into the center.
I think jury's a little bit out on that. I mean, I think if you look at how networks, like large scale networks, even the internet has kind of developed, I think it's a similar pattern, right? So like if you look at something like a public blockchain like Ethereum or Bitcoin or something, think of those like trunks, right? And typically, like even in banking systems, we don't operate at the core level of a banking thing. We're operating out at a branch and whatnot. And the reason is scale and other reasons, obviously security and things like that. So basically, I feel the same patterns happening here, right? We have that core trunk there and it's super important and we need to like tie to it, but we'll be operating out at these leaves or these like side chains. And so I think they will live on for a long time. I think it's just natural.
Okay. So it'll just sort of stay along running on the side. Okay. That makes sense.
Yeah, and the nice thing there is like those things can evolve then too, because what we know about blockchain, 5 years ago versus today versus in the future, it's going to change, right? It evolves too, and so the point is we don't want to be like totally reinventing the wheel each time, right? It should be an evolution. Like, okay, well, we either tweak the software that we had here, or we have this whole new thing and we migrate to it, just like we do with enterprise software.
Is the right? I mean, I'm sure the analogy breaks down somewhere, but is this sort of look like? When we think about, there's the core Linux branch, there's Ubuntu off of this, there's Red Hat off of that, and there's things go back and forth from that main branch to these distros that are off of it, and then distros can push stuff into the main branch, but they're all still, there's a connection back and forth between them at the end of the day. Is that does the analogy break down at that point, or is that still roughly true when you think about these side chains?
Yeah, it's a good thing, right? A good point you bring up there. Even at the most detailed level, that applies, right? So if you took something like public Ethereum, the most predominant one we use in the enterprise is Quorum, right? And Quorum is a fork of Ethereum, right? So it pulls changes actively, right? So as Ethereum evolves,
that's sort of what I
Quorum
was
evolves,
asking.
right?
Okay.
Yeah. That's not always the case. It doesn't have to be, right? Just like in the real world with operating systems, like you bring up the analogy, there's other operating systems out there, right? There's other blockchains out there, and those can interoperate with these to some extent, right? They won't be the exact same, but yeah.
Okay.
Now, Cale, you mentioned that so you're helping customers migrate off what we used to have, which is the blockchain service, into the QBS, right? Which is what we're hosting in Azure now. But if someone were to want to start a new QBS instance, is it just a matter of going to the marketplace and finding one, or is there a special place where they need to go to spin one up?
Yeah, so I mean that's happening as well. I don't think that's officially announced or anything yet, but it will eventually, happen. Right now, it's mostly focused on migration, right? So eventually, yeah, you'll be able to go just spin up new instances. We're kind of concentrating on making sure the migration happens very well for existing customers first. Now that being said, like you can still run this stuff in unmanaged form, and we totally support that and contribute to that as well. There's actually a project called Kubernetes. It starts with a Q instead of K, and that's
you
Quorum.
about lost me there. Okay, I'm good. I'm back now.
Yeah. So it's a Quorum on Kubernetes basically, and I pushed some changes into there to make sure AKS works really well with that. So customers who want to do that, I guess it's not fully unmanaged because the Kubernetes cluster is managed, but it's another variant of the way to run this. I think the other important thing I wanted to bring up here, make sure we hit on, was something that's really hot button issue today with blockchains, and it's coming up a lot in discussions around things like NFTs, as those are becoming more predominant for even maybe a business case and whatnot beyond just pictures and things like that. is the environmental impact, right? So there's a lot of negative press and things about like public blockchains because in the current form, public blockchains, the ones I mentioned, Bitcoin and Ethereum, use proof of work, which is very heavy compute intensive work, right? So you can imagine the carbon impact is quite high for something like that. So, there's a lot of, and it's, duly deserved that, hey, if we start using these public blockchains, we're actually contributing to some negative carbon impact to the world. It's not a good thing. So how are we going to solve this problem, right? So I think, there's a couple things that are happening there that I work with and we've been talking about, and we've actually been using some of the tools in Azure to kind of like benchmark this a little bit, is basically, these side chains that we run that I mentioned before, which will predominantly be used, at least right now, for enterprise and maybe some of these NFT platforms and things. Those basically that run the same algorithms and things that we use for the enterprise blockchains, which don't use proof of work. So the first thing is they're not sitting there needlessly using tons of compute because they don't have to. In those circles on those private blockchains, they're a closed group of friends, we'll call it. So we don't have to have the same controls in place like we do for a public blockchain. And so, or we have different controls rather. So we onboard and offboard people. It's not just any random person can pop into our network. And so basically then we can loosen up some of those things around, the proof of work algorithm. So we use different algorithms. So it's much lower compute. We've actually benchmarked that on Azure. And with our carbon commitment in Azure for compute, I mean, the compute usage is so low that the carbon impact is net zero. So if you're running one of those nodes on the sidechain and it's running in Azure, it's basically net zero carbon impact because of the stuff that we do in Azure to support that as well. Now, on the public side, it still doesn't solve that problem, right? So on these side chains, a lot of times people will say, well, I want to do something that's going to interact back to that trunk like I spoke about earlier. So the interesting thing there is folks have been building these things called bridges that basically make those links back to the mainnet. And the interesting thing there is you can apply rules to that as well. So if something, a transaction traverses that and has to go back to the mainnet, you can impose a carbon tax. Right. So yeah, it's not helping that thing that's running on the other side, but you're actually paying for that carbon usage.
This is a little bit, this may be a little bit further than you were wanting to go, but I assume there is work on the, core blockchain trunk to try and make these, you can always make code more efficient at the end of
Yep.
the day. So I assume there's work going on that side as well.
Yeah. So Ethereum is working on something it's been for a few years now called proof of stake, which is a different consensus algorithm. I think the quote is 99 point something % more efficient than proof of work. So
Okay.
to your point, Evan, yeah, the carbon impact, once that is live, running that node on Azure, a public Ethereum node, will net zero, basically.
But I mean, but even the proof of work stuff, there's got to be work to make that more efficient as well. I mean, you may never get it down to zero, but you're still trying to drive that down at some level, I assume.
Yeah, it's an interesting thing because it varies a little bit between like Bitcoin and Ethereum. Bitcoin has favored an approach where they use exotic hardware, and I say exotic, they're called ASICs. They're application-specific integrated circuits.
Yeah.
See, basically, you buy a special chip to do that thing, and I assume to your extent, what you're talking about, Evan, is maybe that could be improved, as time goes on to help improve that situation. And Ethereum uses off-the-shelf GPUs, which continue to evolve if you can get one.
Yeah,
that's true.
Yeah,
exactly. I was wondering, if somebody were to use or spin up their own blockchain on Azure using, just using some of the procedures that we've outlined, and they're misusing it, like for they're really burning through a lot of the compute and whatnot. Is that something that we track or we look out for? Or it's like, hey, if you're paying for it, we don't really care.
The cool thing is we have a bunch of tools. We just announced one, I think on the 13th of October here, and I think it's an evolution of this thing called the sustainability calculator. So if you're a customer in Azure, you can basically, it's a Power BI, it's free. It's like a Power BI tool that will essentially like use this API to see your consumption data coming off of Azure. Obviously, you have to authenticate it and all that stuff, but basically it'll give you these nice dashboards and tell you those kind of things. So first of all, if you're a company and you're like, no, we're good, and you didn't realize you were doing these things, like this helps there from a visibility perspective. But I think the only thing, and that maybe Evan could talk about this a little bit, was in the past, we had these things in Azure to detect things like mining, which is proof of work. And I think that was mostly targeted at like when people would use like free SKUs or like trial accounts to kind of mine cryptocurrency and things. It's kind of a no-no from a terms of service.
Yeah, it's, I mean, it's, any kind of thing that, the terms of service are supposed to block that. And then, there's always bad actors out there that are trying to get into somebody's account. And once they're in there, they'll try and do mining with it. But yeah, we're always sort of looking for that stuff to make sure that isn't there.
But in general, Sajid, if it was like an enterprise workload and they were using some weird algorithm that actually chewed up a bunch of compute, I don't think it's a huge issue other than their bill might be higher, and so they would probably be more concerned than us about it. Like, hey, we need to make sure it's under control.
But we give them some tool to audit their environment to see, they're accidentally doing something they didn't expect. The other thing that I thought that came to me when you talked about some of the use cases of blockchains today, you mentioned things like chip manufacturing, I think retail, transportation. There's ships we talked about at some point, tracking ships. Yeah, it sounds to me like all of them somehow indirectly need like NFTs, right? Eventually, when it comes down to the wire, everything is tracked via NFT. Is that how we think about NFTs? Like, is NFTs like an integral part of any blockchain application, or can you build a blockchain application without using NFTs?
It's an interesting thing, right? I think NFTs. So there's NFT stands for non-fungible token, which basically means, when we talk about Azure, like cattle versus pets, it's kind of like the pets thing, right? They're very unique and special in the world versus something that's more of a commodity type thing, right? So the fungible is the other side of that. I think they both have use cases, right? There's definitely a use case, a big one for tracking items that are very specific. They have a serial number, they have something that's very unique to them. But there's also a side for the fungible side, right? And that's a little bit like the cryptocurrency side, but if you think about it in terms of, enablement in a supply chain, for instance, let's say if you wanted to enable some sort of digital payment system that happens inside of there, you could use that as well. So I think they both still apply. I don't think we even really don't call them NFTs in the enterprise space. Most of the time, they're called digital assets. But because that can encompass both, right? That could be a fungible or non-fungible asset, but it's a digital asset that exists in there.
Very good. And then another question that came to mind is, as a developer, right, of somebody who's let's say I want to start up. I remember one point I went down the path. I think we were discussing about creating like an open hack of some sort, where people can go and spin up a blockchain system quickly and write a smart contract, let's say, for it. If I were to start one today, do I really have to think about, hey, which system I'm going to be running on? Are the systems so disparate in terms of what they support from an application perspective, or is there at least a uniformity from an application stack perspective when it comes to blocking? Like, I don't care, you run on, Ethereum or Quorum or whatever, system, it'll just work, right? How does a developer think about it?
It's a really good question, right? So I'll answer it in a couple different ways. So the first thing is they still are very specific, meaning like the smart contract language that you use or how you define what we call quote unquote a smart contract or some of the code that's going to run as part of it is still pretty different, right, between the different platforms. So when you're picking one, it's kind of like picking C# versus Java versus JavaScript or something like that at that level. So you're still picking those kind of languages, like high level language, how you're going to define this thing. The networks themselves are easier to spin up, obviously, over time. That's gotten much better. So I would say that's more like a DevOps thing, right? You know how to like spin these things up now, and here's how you do your deployments. So it's all traditional kind of software dev stuff there. I think the important thing though is the standards that have come out specifically around digital assets. I feel like these are super important, right? Because people you're making a choice today. You say, hey, I'm going to go with this blockchain. It seems like it meets my needs from scalability, security, whatever I need. So you build your stuff on there. Let's say in the future, something else better comes out, or that thing goes out of business, or whatnot. Something could change there, right? And you say, now I'm locked into this platform. And if it is something like a digital asset that has to live on for a long time, you don't want to be locked into something like that, right? So I always tell people, and when we're working with them, is like, let's follow those standards as much as possible we can for those tokens or the digital assets we're using. This way it makes it portable, right? So much easier to say like, okay, I was working with company A. It turns out that's not profitable for them anymore. So now we're going to go to company B. How do I get my assets over there? Okay, well, we can build a bridge. And if we're using these standards, it makes that process much smoother, right? But again, it's very much just like software dev that we've done for many years, right? When we migrate from database A to database B, there was a translation that had to happen there. So the more you can cut that down by using those standards, the better off you are, right? Because then you protect yourself, kind of like we say multi-cloud or we say multi-blockchain, these kind of things. You're protecting yourself a little.
Awesome. That's great. Thanks. This has been really helpful. Thanks, Cale, for bringing us up to date on the whole blockchain scene. Any last words you want to share about any resources that listeners can go to, or what they can do to get more educated on what's happening in the space?
Yeah, I'll definitely drop some links out. Just one other thing I wanted to mention is, from Microsoft's perspective, like, after working on this for many years, blockchain has kind of like spread into other things that maybe some of our customers or listeners have heard about. So two of them I'll mention here is SQL Server. So we have a product now called SQL Ledger, which is basically a cryptographically verifiable record in a SQL Server. So you turn on this flag in there, and it's using some blockchain technology. It's not a blockchain, I want to be clear about that, but it's using blockchain technology inside of there to provide those guarantees around a transaction that happened at SQL Server. Really, really cool product that's going to continue to evolve. The other one is called CCF, Confidential Consortium Framework. This is one led by, Mark Russinovich and MSR originally, but it's kind of grown up. And it's basically using secure enclaves, as we mentioned in the news, to do something similar. Again, I think of it more of as a ledger than a blockchain, and we could have a whole show about what that means. But basically, it's using some blockchain technology, but it's also using some new hardware like SGX and others to do that. So people should check that out. I'll put some links in the notes for that as well.
That is very cool. I didn't know that SQL Server has blockchain technology now. That is amazing.
That might be the connection here that's going to force me to go look at this deeper.
There you go. I was about to say, Evan, how did you not know about this? Well,
Okay.
Cale, thank you again. For Evan, any questions for Cale before we
No,
wrap
I
up?
was just going to say, Cale, we give you a hard time, but I mean, every time we have these conversations, I learn so much about blockchain. So very much appreciate it.
Yeah, no worries. Thanks, everyone.
Thanks. Thank
Thanks,
you for
folks.
keeping us all informed.